Welcome. This is the Page 33 video, which we're just going to create the slick efficient modular exponentiation algorithm. Hard to say. Okay, so the example we want to do here is we're going to compute 73 to the 29th power in z sub 151. So this is going to be slightly a nightmare to do by hand, but we'll just need to do a few of these to get the idea. So we make a chart. In the first column of the chart, we put the powers of 2. Sorry, the successive powers of 2 of 73. So the first one is 73, and then we square that. So I take out my calculator and I compute 73 times 73 is 5329. So 73 squared is 5329, which is a perfectly good number, but of course we want it to be reduced in Z151. So I take the 5329 I have sitting in my calculator and I divide it by 151. I get 35 points and change. Then I subtract the 35 and multiply back by the 151. So fairly quickly, by that technique we studied on an earlier video, you can do this. So then 74 is, sorry, eraser time. Sorry about the tapping, but there's something wrong with my microphone, so I can't have to use the built-in microphone or the tapping is loud. So 73 squared is 44, so 73 squared, which is 73 to the 4th, is 44 squared, which is, so 44 times 44, 1936. And then we reduce that by dividing it by 151, getting 12 and change, subtracting the 12, and multiplying back by 151 to get 124. And we continue like that, so 73 to the 8th is 124 squared, the previous value squared, which is 24 squared, 124 raised to the, stupid calculator, 124 squared is 15,376. And we don't really care, divide by 151, get 101 point something, so I subtract the 101, get the change, multiply it by that, so it's 125. And finally, speeding up just a smidge, 73 to the 16th is equal to 125 squared is 15,625, and that is equal to minus 103 times 1 is equal to 72. Okay, so those are the powers. 73 raised to the various powers of 2, and so all we have to do is figure out what 29 is and multiply those together like we did before. But this is not slick because with a little more work we could have merged in another algorithm. The other algorithm is how to convert 29 to base 2. So to convert 29 to base 2, you write down 29, and then that is odd, so that means the last bit of 29 is 1. Then we recursively we divide 29 by 2, so we get 14, so that's even, so the next bit is 0. And then we divide by 2 again, that's 7, which gives us 1. Divide by 2 is odd. Divide by 2 is 1, and then divide by 2 we get 0, so we stop. So this is this number right here 11101 tells us that the 1s, the 2s, the 4s, the 8s, and the 16s column, and we can check. So 16 plus 8 plus 4 plus 1 is in fact equal to 29. Okay, so that means up here in our previous chart we have to include the number for 73 to the 1, to the 4, to the 8, and to the 16. So we multiply all those together. So our answer for 73 to the 29 is just 73 times 124 times 125 times 72. So we can do that laboriously. So 73 times 124 is this, divided by 151 minus 59 times 151. So these two multiply together to form 143. And then I multiply 143 by the next number, 125. Divide it by 151, subtract 118, times by 151, and so times 125, so 143 times 125 is 57. So finally we do 57 times 72 divided by 151 minus 27 times 151, and we get the grand answer of 27. Which I believe is what we came up with in the notes. Okay, so this is not the final algorithm, but it's really close to the final algorithm. So let's add and go to a next. Okay, here on the next page, we want to look at the slick version of the algorithm, and it's really quite simple. I'm not going to do all the arithmetic again. So we start off with 73. That's 73 to the 1. But now we start with A and E, and then off to the right we have the cumulative answer, or the cumulative result. So at the beginning, because 29 is odd, we use the number 73. So we write down 73. That's the cumulative answer. Then the next thing we did was square 73, and if you remember, we got 44. And we cut in this column. We do the merge in the converting to 2. So since 14 is even, so 29 is odd, so we use the 73. 14 is even, so we don't use the 44. Okay, then we square 44, getting 124, and we divide the 14 by 2, and that's odd. So now, over right here, we put in 73 times 124. So that is 73 times 124 equals, divided by 151, minus 59 times 151. So that gives us 143. In this spot. And if you look back at the previous work, that's probably what we had. Yeah, actually, yeah, that's 73 times 44, which was what we did the first time when we were doing it the other way. Okay, then we square 124, getting 125, divide 7 by 3, and since this is odd, we use, so we do the cumulative 143 times the number for this row, and that gives us 43 times 125 divided by 151 minus 118. That gives us 57. And then we square this again. Square 125, you get 72, divide 3 by 1. And since that is again odd, we do 57 times 72. So the number above times the number for the current row, and that is 57 times 72 divided by 151 minus 27 times 151, which is equal to 27. And that's the answer. Ta-da! So that's the slick algorithm, and it's, if you pause now you should, and I don't know how much of this I'm going to do for you, but if you look at embedded exercise 26, it's a similar chart. And when you should try to look at that chart on page 34, I guess it'll be, yeah, page 34 in the pre-reading material, and just kind of make sure you understand what's going on in that chart. So this is computing 29,613 to the 8075 power in Z sub 31861. So the arithmetic gets pretty crazy. So I'm going to pause here, or you should pause the video, and when you come back, I'll do a few steps of showing what's going on in that chart. Okay, so hopefully you actually did that. So let's take a look. I think I'm going to go to a next page. Okay, so we start off with, if we want to compute 29613 to the 8075, we just write these down. And so the first value, cumulative value, because this is odd, we just write down 29613. So that's saying that the number to the 1 is included. Okay, now on the calculator we have to square 29613. So I do 29613 raised to the 2 is some long, 10-digit number, 9 or 10, whatever. And then I just divide that by 31861. And then I subtract 27523, and multiply back by 31861. And I get 19466. Yay. Okay, and then I also have to divide 8075 by 2, and if I can do that in my head, that's fine. So half of 74 is what, 37. Okay, oops. Now in this row, because this is odd, I multiply the number here by the cumulative number so far. So I'm going to do 19466 times 29613, getting some humongous number, divide it by 31861, minus 10892, times 31861. Oops, oh yeah, 17446, which checks what's in the notes, in the print pre-reading. Okay, so I'm going to do one more. So I square, maybe one more. This is so much fun. Equals that. I subtract 11893. And then multiply back by 31861. So I get 2283. 2283. And then 4037, I'm just going to do on the calculator because my brain's tired. So it's 2018. You always drop the remainder. Okay, now, since this is since this is even, I don't multiply 2283. So this is my number to the 1 and my number to the 2. So I'm not using the number to the 4th, but I am multiplying. So 17446 is actually the a to the 1 times a to the 2 cumulatively. But I skipped this one. So the next one, 2283 squared divided by 31861 minus 163 times 31861 is equal to 1874546. Sorry. All right, I'm going to clean that up. Okay, and 2018, I can do that in my head. So that's odd. So finally, because this is odd, we take, so this is a to the 8th. So we're coming up with a to the 1, a to the 2, a to the 8th. So far our exponent is added up to 11. This is a long ways from 8075. But anyway, I take 18746 times 17446, the cumulative values so far. Then I divide that by 31861 and subtract 10264 and multiply by 31861, getting 21412. 21412. Okay, and then it continues like that. And of course, it has to continue until we get down to 1 here. So, but how long does it take? It takes the log base 2 of the exponent steps. So no matter how painful this process is, assuming you can do the arithmetic for 1 step, then it doesn't take that many steps. So even if E is huge, it's okay. And also notice that if A and N are huge, that causes a fair amount of work too. But E is the thing that drives how many steps there are in the chart. Okay, so I think, oh, and the folder in the course website, there's a folder named Code, and in that folder there's another folder named RSA. In that folder there's a class, Java class named modexp. So if you just run that guy and enter in, I guess, A, E, and N, it'll produce one of these charts for you. So later when we're actually doing some routine exercises, that guy will be helpful to avoid doing all this insane arithmetic. But you still want to be able to do these steps using a calculator for the test. Okay, so that concludes this video. Thank you.